Hi, I will present our paper Processing and Acquisition Traces in Visual Encoders. What does Clip know about your camera? Given the following image, can you identify the JPEG compression parameters used? How about the camera model or the aperture? It turns out that some pre-trained foundation models can. Therefore, metadata leaves traces in the representation space of these models. Surprisingly, we additionally show that such metadata traces affect semantic recognition abilities. We consider different foundation models, which we categorize into three groups according to their training schemes. Contrastive vision language models trained for vision language alignment, supervised models trained with image classification supervision on ImageNet, and self-supervised learning models trained with contrastive learning. We keep these models frozen and use them to extract image representations. We also consider two types of image metadata: processing parameters applied to images such as JPEG compression and the image acquisition parameters such as the camera model. First, we ask whether linear probing on top of the representations from frozen foundation models can be used to predict these metadata labels. For the prediction of processing-based labels, we apply different kinds of processing, for example, JPEG compression with different quality values, and train a linear classifier to predict this value. We observe that for JPEG compression, many models perform above the random chance. Contrastive vision language models compared to other types of models show the highest ability to recognize processing-based labels. Additionally, many supervised models also perform well. On the other hand, self-supervised models generally perform the worst on this task. We observe the same trend for other processing parameters as well. For the prediction of acquisition-based labels, we collect a dataset of flicker images with their accompanying EXIF metadata. Before passing the images through the foundation models, we mask 90% of their area to remove any potential correlation between the acquisition-based label and the semantic content. We then train a linear classifier to predict the used acquisition parameters. We observe that contrastive vision language models can predict the acquisition parameters such as the camera maker with a high ability. Moreover, supervised models also show high accuracy in this task. In contrast, the self-supervised models perform the worst. We observe the same trend for other acquisition parameters as well. Now that we know that some foundation models encode metadata information, we ask whether its presence can distract semantic prediction abilities. To evaluate the influence of processing parameters, we consider a task of KNN classification on standard benchmarks such as ImageNet in three setups with a different training set per test image. In the first one, which serves as a baseline, all training and test images are processed using the same processing parameters. In the second one, pos same, there is a correlation between the semantic and processing labels, such that the test image and training images that share the same semantic label use the same processing, while other training images use different processing. In the third one, neg same, there is an anti-correlation between the semantic and processing labels, such that a test image and training images that do not share the same semantic label use the same processing, while other training images use different processing. If the processing parameters affect the classification, we should see an improved performance in the pos-same setup and a lower performance in the neg-same setup compared to the baseline. For JPEG compression, we observe that compared to the baseline setup, contrastive vision language models and some supervised models show improved performance when there is a correlation between the semantic and processing labels. On the other hand, they show a worse performance when there is anti-correlation between the semantic and processing labels. However, the self-supervised models mostly show a consistent performance in all three setups. This shows that the semantic recognition abilities of the models that encode metadata are affected by this metadata information. We observe the same behavior for other processing parameters as well. To evaluate the influence of acquisition parameters, we consider a task of near-duplicate image retrieval in two setups with a different database for each query image. In the first one, all database images are taken with a different camera model than the query. In the second one, the semantic negatives in the database are taken with the same camera as the query, while the semantic positive is taken with a different camera. If the acquisition parameters affect the retrieval, we should see a lower performance in the second setup as the semantic negatives share the same camera model as the query. We observe exactly this for some contrastive vision language models and some supervised models, as they obtain lower performance when the semantic negatives are taken with the same camera as the query. To learn more, check out our paper where we also hint at potential reasons why some models are more sensitive to the metadata than others.